So, in the past, and in my opinion, out of these three things, I feel like the solutions vocabulary is going to be the hardest, just because you're given a definition and you have to figure out the word. And fortunately, there's no word bank, okay? So, you gotta know what a solution is, solvents, unsaturated, all that. So, so with the vocab, I'm gonna use actually this pen. So with the solution, what are two parts of a solution? Yes, solute and solvent. So let's start with solute. How would you define solute? Like with salt water. So which one? So salt water. Which one would be the solute? Salt or water? The salts. So what is the salt doing? It's being dissolved, exactly. So the part of the solution being dissolved. So in this case, the example would be salts or sugar or Kool-Aid. Then we've got water. Well, solvents. Water. So how do you define solvents? It's the part of a solution that what? Part of, oh my goodness, I can't write. Part of a solution doing the dissolving. So it's the thing that dissolves a solute. .99% of the time, solvent is a liquid. Alright, oh, by the way, everyone has their, I think most of the tables already have this graph on the table, right? If you do not have it, because, morning classes, they already have this on there, but if you don't have it on your table, I have the class set up there, so, because we're going to eventually talk about this as well. So, speaking of, we've got unsaturated, saturated, supersaturated. So what is unsaturated? So it's below the wanted amount? Yes. So I'm going to give you a similar keyword. So if you see that same word, you know what it is. So it's a solution when it has less, keyword less, than the maximum amount.
Would it say below the line or above the line?
No. Okay. That's why I'm giving you this definition, so you know that an unsaturated solution has a less than the maximum amount a solution can hold. Alright, what is saturated? Maximum amount, exactly. I can't spell holds there. I'm going to say max amount. So, y'all probably get the pattern by now. So, supersaturated is what? More than the max, yeah. More than the max amount. Underlining for a reason. So on the quiz tomorrow, the vocab part, you'll be given 4. I have given you 5. So 4 out of the 5 will be given. I won't tell you which 4, but it's just safe for you to know all of these. But it's not too terrible.
So how many questions are there?
10 10 questions. Yeah. All right. So, any questions on the vocab? It's just memorization. All right. Next, solubility curve. So this is where you have to have your graph in front of you. I can't really draw the graph on the paper, so we're just going to use that. And I'm going to give you some sample questions. So let's talk about the unsaturated, saturated, supersaturated again. So when it comes to the graph, how do you know if a solution is unsaturated? Below the line. And I like to say under the line because it's easy to remember. Under, unsaturated. So we know that saturated is a perfect amount, so it's on the line. Then supersaturated is what? Over the line. By the way, if a question asks, like, what's the saturation, please don't put oversaturated. That's a common mistake. That's not the correct term. You have to say supersaturated. Alright? So, y'all have your graphs in front of you. Let me give you a sample question. What is the solubility of KNO3 at 40 degrees Celsius, 75 grams? Alright, so whenever they give you temperature and grams, that's when you just pinpoint on the graph and you have to say saturated, supersaturated, unsaturated. That's why they give you both of these. So when you look at KNO3, by the way, on your quiz, the graph will be on your quiz paper, and I promise it's easy to read. Okay, I made sure of that. So KNO3, we're going to look at, let me see, like that. This line here, we're going to find the temperature, what did I say, 40 degrees, 75 grams, which is right here. So it's about here. It is super saturated. Good. Alright, how many grams of NaNO3 will dissolve at 20 degrees Celsius? Now in this case, it only gives you the temperature. So let me rewind for a second. Temperature and grams, you look at, you pinpoint on the graph and say the saturation. Temperature only, you have to figure out on the line. Okay? So if you want to make that note for yourself, you can do that. So NaNO3 is this line over here, and what did I say, 20 degrees? And go to 20 degrees Celsius, and you go all the way up to the line. So roughly, I'm sorry? Around 88 grams. Good. 87, 88, that's fine. As long as you don't say 60 or 100, that's way off. But as long as you're super close, that's fine. Alright, this next one is a huge hint, hint, wink, wink, nudge, nudge. How many grams will precipitate out? Oh shoot, I should probably tell you what line is. KNO3, let's do that. when it's cooled from 60 degrees to 40 degrees. Alright, so this common missed question. Let me give you a second to write this out because I want you to actually listen and understand what I'm saying. Is this better to read?
Yes.
Okay, sorry about that. If y'all need me to zoom in, don't be shy, tell me. Okay, so let's take a look at this graph for a second. Notice how these curves go up, right? That means as you increase the temperature, the solubility goes up. It dissolves faster, dissolves better, right? Think about, coffee. I mentioned this before, iced coffee versus hot coffee. When you put sugar, which one would dissolve the fastest? The hot coffee, exactly, because that temperature really melts down the sugar. So, however, when you cool the temperature, it undissolves itself. So it precipitates out. That means it forms that solid. So what you do is that you find KNO3 right here. I need to zoom out again. I'm sorry. All right. And then you're going to find the two temperatures on the line. So 60 versus 40. So we have 60 degrees. You go up to the line. So it's about what? 100. Is it 100? Yeah, 100. 40 degrees Celsius?
60.
About 60. So 100 versus 60. What is the difference? 40 grams. That's all it is.
Could you go over, like, whenever the mass of the water is, like, 200 or something?
Sure. I don't think it's going to be on the quiz, but sure, absolutely. So let's say, actually, let me write it out. I'm going to totally make this up, so hopefully I don't mess this up. Whatever, 20 degrees, 50 grams, in... Alright, I'm actually glad you brought this up, because this is a nice challenge. Alright, so what is the solubility? Oh, come on. Alright, what is the solubility of NH3 at 20 degrees, 50 grams in 200 milliliters of water? Okay, so notice on these questions I didn't mention the number of mils of water. Just always assume you just use the graph itself. But whenever it gives you a different, other than 100 mils of water, that's when you ratio it. So you don't have to do this stuff, but it is easier to figure out and you don't mess it up. So you have 20 degrees Celsius in 200 mils of water. However, our graph has 100 mils of water. So that's half of 200. So what do we do to our temperature? Well, no, not real. So you just divide by 2. So 200 to 100 is divide by 2. And then we have to do the same thing, divide by 2. So instead of looking for 20 degrees, we look at 10 degrees. I'm sorry? No, just the temperature. Because we have 50 grams, but the temperature is different. Yeah, so we look for 10 degrees, 50 grams, right here. And did I say NH3? Did I say that?
Yes.
So, okay, so we look at this. So what is it? Saturated, unsaturated, supersaturated? Unsaturated. Okay, good. So notice if I did 20 degrees, it would be roughly here. I mean, it is still unsaturated, but maybe it would be saturated, so you got to be careful there. But
So say you gave us at 20 degrees, would you take E or 1?
say that again?
Go back to the graph.
Yeah.
You said 20.
Yeah.
So it's right, would you take saturated and unsaturated? Or would you take
Well, I mean, I would still say unsaturated because it's still a good amount. So, but if it's something like this that's kind of hard to read, then yeah, I would take either or. Yeah, good question. Okay, so another thing I want to mention, this is a big hint, wink, wink, nudge, nudge. I can't really write this out, so I'll just explain it because we did talk about this before. So remember in our graph here, hopefully y'all remember what we talked about. Notice how all of these are curving upwards, except these two are curving downwards, the NH3 and the cesium sulfate, okay? Do y'all remember why these are curving down? It's a gas, yeah. So all these curving up is a solid, so it's like salt. They dissolve in water, and they make a solution. However, these are gases dissolved in water. However, it goes down. The solubility decreases as the temperature increases. Okay. So again, we talked about the coffee. As you increase the temperature, it dissolves faster because when you put the sugar, it's solid. But with the gas, it undissolves itself when you increase the temperature. Because again, I talked about soda before. It's fizzy. There's gas solubility in there. So if you take a cold soda, you open it and you leave it in the sun, what happens to the soda? I'm sorry? The bubbles go away, the gas goes away, so it gets flat, right? Because the temperature is increasing, there's not really much gas anymore, okay? So if, hypothetically, I ask what factor of solubility negatively affects gases, what would that be? Temperature. Okay, so that's the one factor that's opposite between solid and gases. If you need to write that down, I would. Okay.
Say what factor of
solubility. Yeah, because remember we talked about temperature being a factor, agitation being a factor. Agitation meaning like we shake a solution for it to dissolve. Surface area is a factor, like how big or how small the solute is. Talk about like regular sugar versus sugar cube. Which one would dissolve faster? The regular sugar or the sugar cube? The regular sugar, exactly. It has more area to cover. Yeah, so those three things affect how something dissolves. Okay? Any questions on solubility curve? May I flip over? Alright, so we're going to do one more thing, the molarity dilutions. It should be fairly quick because we just did this yesterday. Unless if you were absent, I would pay close attention so you're not behind. Alright, so we have this equation and this equation, and you will be given this, so you don't have to memorize it, but it's pretty easy to remember. And then for molarity, for this equation, it has to be in liters, okay? So if the question has it in milliliters, what do? Divide by 1,000. However, this equation, the dilutions, you can keep it in milliliters, as long as both V1 and V2 are in the same unit. Alright? So let's do one question. We'll do one question of each. Okay? Alright, what is the molarity of 15.3 grams of NaCl in 1.5 liter solution? Uh-oh, it's in grams. What's the first thing you do? Divide by something. You divide by the mass of NaCl from the periodic table, so I trust you know how to do that. But on the quiz tomorrow, you have to find it yourself. So the grams of NaCl is 58.443. Okay, and now you take the 15.3 divided by 58.443, you get 0.262 moles. And that's when you plug it in to your equation. .262 divided by 1.5 equals. What'd y'all get? I got the answer, but I don't want to give it to you right now. All you have to do is divide. Ouch. Careful. Y'all should have gotten your calculators out at the beginning of class. Point what? 174 or set? I got 0.174.
But what do we round up?
Yeah, let's do 3 decimal places. So yeah, that would be 0.175 molar. Big M. Please don't put small m. That's wrong. Please add your units.
It's the same number. I just put the decimal in the wrong spot.
Yeah, but that affects the answer, so careful. Yeah. I'll be honest, I've been pretty lenient with the units, but I'm kind of tired of being nice, so you add the units, please. So, okay, and I want to mention this. What if you're given, like, the question, but it's in moles? You just plug it in, okay? Be careful. So, I know we've been doing this a lot, the divided by the mass periodic table. Don't do it all the time. Once you see grams, you pull out your periodic table. If you don't see grams, don't even look at the periodic table. Okay? Any questions? Molarity.
So if, let's just say 15.3 is in moles, you would divide 15.3 divided by 5.
Yep, you just plug it in. That's it. Alright, I'll give you one more. We'll call it a day. What time is it? Oh, we got time. Alright, for dilutions, again, in the past I had, and I really hope y'all don't ask me tomorrow, I'll be super annoyed. Don't tell me, oh, which one's V1, which one's V2. I'm not going to answer that, okay? So, if you haven't been paying attention now, which some of you haven't, remember, I'm watching y'all. Yeah, I'm taking mental notes, just paying attention or not. So, if you haven't been paying attention yet, now's the time. So, what volume is needed to dilute? What? A 18.5 molar solution to 500 milliliters. 13.5. That 13.5 molar solution. All right. So again, I know you know how to algebra. You know how to plug it into the calculator. It's all about reading. You have to read. So, let's break it down. What volume is needed? We talked about it yesterday. Is that V1 or V2? V1. Perfect. So, V1 is question mark. So, we have 2. So, that makes 500 mils what? V2. We got 18.5 versus 13.5. Again, dilution means to increase the molarity or decrease the molarity. When you dilute water something down, you decrease the molarity. So, the bigger number would have to be what?
1.
M1. That's what you're starting with. M2 would be the 13.5. That's the hard part, which isn't actually that hard. Then you plug and chug. So I have 18.5 times V1 equals 13.5 times V2, which is 500. Notice I'm leaving it in milliliters because you don't have to convert for that. If it specifies, like, hey, I need this in liters, that's when you convert. But, so I divide by 18.5. Again, another thing I want to mention, don't ask me tomorrow, wait, do I divide it this way or this way? I'm not going to answer that, okay? You have to know this yourself. This is Algebra 1 stuff. Alright, so when you get your V1, it is 364.86 watts. Milliliters. Perfect.
So is the first volume always going to be nuts or just like?
It doesn't matter because it depends on your concentrations. Yeah. All right. Any questions for me? Yes. All right, you may have the same question. Listen up, ladies.
Why does it matter which one's V1 and V2? Does it match the same both sides, like no matter what side?
It says what volume is needed. So think of a solution, right? And you want to dilute it. And it's saying, I need this much of this new concentration. So how much volume do I need to add to get this final, concentration? That's what that means. Yes.
But it could be on either side. Like you could have M1, M2 on one side and V2.
It's about the understanding the concept of dilutions because you got to know that with dilutions you got to decrease the concentration. So,
Okay.
yeah. All right. Cool. I'm going to end this video right here. Oh, I have not fulfilled the 30 minutes, so it is watchable. Cool.